Good afternoon, sir.
Sir.
Sir, sir, please unmute yourself, sir.
Hello. Yeah, please. Good afternoon.
Sir, should I start, sir?
Oh, okay. But people are not
Very
there.
less. Yes, they will join in the meantime.
Was there a
sir.
break now?
No. So actually, our last session ended at I think 3:30. So
okay.
we are giving 15 minutes break.
Okay. Oh, all right. So maybe just 1 or 2 minutes. We'll anyway. I can sort of finish it off quickly. Let us see if another 2 minutes, if somebody is joining,
Okay.
and then we'll start.
Okay, no problem, sir.
Yeah, just a couple of minutes. We'll anyway start then. Okay.
Okay, sir. Okay, sir.
पूरा करें तो लॉग आउट हो जाए सेठी बस करें
Thanks. Okay. I think in another 2 minutes we'll anyway start. When we'll sort of try to finish it before the valedictory process, or it's sort of can fade into the valedictory, but we'll finish accordingly. You may let me know the time. I mean, so that I mean, I whatever I want to say in the valedictory, also I will sort of add it in this itself, 1 or 2 points, and then we can have the inputs from others, and you all can give your inputs. Okay, yeah. So maybe we'll start at 3 then. Sorry, 4. I mean, it's literally 4.
Okay, sir, no problem. So we can merge that valedictory function also,
Yeah.
ceremony also.
Yeah, that's what we'll merge it. I'll end with some of the points for that also. But just another 2-3 minutes, maybe. Now, what is the time? 5, 3, 4, 3:59, 40. What is it?
Actually, 3:56.
Okay, another two. So 4 o'clock we will start whatever, whether there are people or not, because not even 50% is there. So just at 4 o'clock, whatever is the process, we'll start. Okay.
Oh, okay,
Thanks.
sir.
Yeah.
ଆମର
Sir, shall we start?
Yeah, I think we should start. It's already time. We'll finish off in time also. Yeah. Okay. No problem.
Anup sir, please start. Sir, you are muted. Anup sir, muted.
Okay. Good afternoon to everyone. So we are heading towards the last session of the FDP, as well as we are also opening the closing ceremony. So we have with us our Vice Chancellor Sir, Professor B.S. Satyanarayan, our HOD Madam, Professor Ranjita Mahanti, Coordinator, Professor Rudranayan Mahapatra. So welcome to our closing ceremony of the FDP. So now I request our Vice Chancellor Sir will address the gathering. So before addressing the gathering, so now I must say something about our Vice Chancellor Sir. So Professor Satan sir holds a PhD degree in electrical engineering from Cambridge University, UK. He has 35 years of experience working in industry, R&D institution, policy planning and academics in India, Japan and UK, and working with global partners including USA, Germany, Singapore, or various countries. He has published over 175 papers in journals and conference proceedings. So he holds 4 patents and has filed another 10 patents. He also won multiple awards for leadership, technology development, research, and industry academic engagement. Sir, over to you. Please address the gathering.
Okay, thank you very much for the kind introduction. And I know, I mean, we are quite late, starting, and as usual, I think people have also taken a break, and I hope they will be joining back. And so as they come, so I just want, the way I want to make this presentation is that, see, you have heard so many things about waste processing, material processing, some aspects of manufacturing, but the major focus of the, overall focus of the FDP was that, what is it, why are we looking at green technology and waste management as a key enabler for advanced manufacturing and circular economy? By advanced manufacturing, I mean literally anything and everything. For any manufacturing, why is green technology essential? Why is waste management essential? And why all of this should be looked in the prism of sustainable development or circular economy. These are the points we wanted to holistically address. But I think we have, of course, addressed it to a great extent, wide range, as I said, of biomass-based energy generation, waste processing, some aspects of material processing and minimizing waste in materials over the last 12, 13 plus hours and inauguration. So maybe what I want to do now is give a quick overview of why should we look at green energy and waste management in the context of the opportunities and sustainable development and in terms of circular economy, and why materials is a key enabler for all of this, and why green energy is key enabler, and while dealing with this, how waste management on one side is useful just to minimize waste, other side it can also be a source of energy, and how all, and the type of opportunities, I'm sure, the diversity of opportunity that these give us is mind-blowing. So I just want you to just possibly have a look at the type of opportunities that, say, these technologies or that we need to address, which are emerging, and where the opportunity is huge, is what I want to showcase. So it would be more, essentially, I think my talk would be more about, and plus, can we do something? Now, having said all of this, is our Indian academic system capable of doing some of this cutting, and show examples of how across the board, from electrical propulsion or satellite launch capability to sensors to electrical vehicle to automobile to material processing at 1/1000th of a temperature, like something was done at 1200, can I literally do that material at, say, today room temperature? I mean, is the type of examples done in Indian academic system that I want to showcase. And most of the examples that I'm showing have all been done in the last 10 years in the institutions where I had an opportunity to work, or where we actually created from nothing some of this opportunity. So saying that if a fool like me can do in 10 years, maybe 1,000 crores of activity with having nothing, and with young faculty, I am sure most of the excellent advanced faculty here who are sitting in this presentation with your colleagues in your own institutions can address mind-blowing opportunity. This is what I want to convey. And I know, I mean, I think I have a large number of slides, and so you don't have to worry too much about these slides. It is more about, as I said, to convey that, I mean, what is the type of opportunity? Unlimited opportunity. Or in general, to say that today the opportunity is, I mean, beyond our imagination. The only thing that can limit us actually is our imagination. And therefore, can we just look at this opportunity? Are we willing to take up this opportunity? And like, I mean, so these are some of the points, as I said, I want to convey. Or if that is conveyed, I believe my talk more than the and showing the diversity of things that have been done. So it is like sitting in a train or going in a flight, and you see so many scenes. I mean, fast moving scenes, but sometimes some scene catches your mind, something maybe sometimes doesn't catch your mind. But the key is that we want you to hold these thoughts, that see wide range of things are feasible today within our academic system, and the only thing that limits us is our imagination. And if we are willing, we can make anything and everything may happen. And so with this brief introduction, maybe I will shift to my presentation. And hopefully, as I said, I mean, I apologize if some of my slides overlap, because as I said, somewhere, I mean, I have maybe tried to put so many examples, but sometimes the examples are repeating themselves. So I would apologize if an example repeats itself. But the key point is to say that we have exciting opportunity, and why not? And all this has to happen with a multidisciplinary approach. I mean, these are some things I want to sort of highlight in my presentation. And hopefully this gives you all an insight into the type of opportunities. Okay, so can I share my presentation?
Sir. Yes, sir.
Okay, where is share?
Sir, present now. The button is present now.
Oh, okay, all right.
In that, you can enter the screen.
And just a minute. Too many things are opened, sir. Is it visible now?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, 1 minute. Can you hear me?
Yes, sir.
Is it visible?
Yes, sir.
Yes,
But
sir.
you should do the full screen mode, sir.
Yeah. I mean, I'll do that. Is it visible now?
Not
I'm
yet.
not able to hear anything from. Are there actually? What is happening? Why is it not coming? Are you able to hear me? I'm not able
Yes.
to hear anything.
Yes, sir. We can hear you, sir.
Okay. Uh, so is it full screen now?
Yes, sir.
Okay. All right. Thank you. All right.
No,
So,
sir. Actually, it is not full screen. It is actually we are seeing that different PPT mode, PPT slide.
okay. I
Just
think accidentally two are opened, I presume. Okay. Just a minute. Are you still able to see my screen?
no, sir.
Sir, you just do one thing. You just open first the PPT, then you just open it, share it, then share it. First you open it, one PPT.
PPT is.
First you, one slide you just share, means open it, then you can share it.
Sorry, I mean, I don't know. Suddenly, why is it causing such? Normally, there should not be a problem. Okay, is it visible something?
Yeah, yes, sir.
Yes, sir.
Is it full screen?
Not yet, sir. So you just do, sir, full screen.
Why is, I mean, every time when I go to full screen, suddenly I am seeing two PPTs. Here I see a full screen on my screen.
Actually, sir, you can do one thing, sir. Sir, just go for your entire screen mode and then share the PPT. So that will be good.
Okay. Is there two windows open of the conference? I don't know. Let me just log in one.
Sir, मैं जाऊँ क्या?
Oh, you can, sir, go.
Okay.
Hello.
Hello, sir.
Yeah. No, why, I mean,
It is not still at full screen mode.
okay. No, I have already done it in full screen. I am. Why? Yeah, just a minute. Why is it? Yeah, please. I am in the full screen, and for some reason, it so looks like a foolish thing that. Just a minute. Escape. Where is the?
That button.
No. Okay. And see, I mean, and I do this, I say window.
No window, sir. Your entire screen.
Okay. No, but it is not giving
No,
me.
sir. Click that one.
Huh?
Click that one.
Huh.
And share. Then you open the PPT.
Oh. Now is it with?
Then click. Okay.
No.
Yeah, now it is okay, sir.
All right. So I don't know. Every day, I mean, I had never had a problem. Thank you. Sorry for the delay. I think, okay, I'll just not take too much of your time. But as I already mentioned, the key essence of what we want to convey is that why should we be talking about green technologies and waste management and about advanced manufacturing and circular economy? Because without the two, all this linking together, we will not have a sustainable world in the future. Because most of the current evaluation of the universe happened in a very unsustainable way over the last just 300 to 400 years when the developed world developed, and they now talk of shared but differential responsibilities, but they only want us to do all the sharing, but the differential responsibility no part of the world wants to hold. But we have no opportunity, I mean, no way but to move towards, I mean, taking up more and more clean and sustainable processes for anything and everything, whether it is agriculture, whether it is manufacturing, whether it is energy generation, whether it is transport. And therefore, and for doing all of that, one of the key things is how do we generate clean energy and how do we manage our waste? That is why we have tried to combine the two. And why are we talking it in a faculty development program is even more critical. And that is where I think we need to say something about our new education policy and also finally our opportunity. Before going to that, I think already Professor Ranjita and others have spoken about the institute. I'll not take much time except to say that I'll take half a minute at the most about the institute. Let's say we as a new university have set a vision that say we want to excel in pursuit of knowledge, linking skills and creating innovation, and therefore creating a change at par with the world. And therefore to do that, it cannot happen as business as usual of just teaching and passing exam. But this also holds good for all of us in the new education policy. And as far as, again, this just says that, see, we have some of the blue color is the existing faculty or programs which will happen, and then green is the new departments that will happen in the university. And we are an institution which have, I mean, our engineering college has been over the last 6 years recognized as a top 100 in NIRF, and that is the bedrock or the main founding enabler of the university. Even we have already now started agriculture, we'll soon have management and law. We, of course, the physics and chemistry, physical sciences will become an independent department, social sciences will become separate. We already have food catering institute along with biotechnology, so all that will become part of, along with agriculture, maybe an entirely food technology linked institution. So this is and plus to do all of our activity, as Dr. Ranjita and others had already presented, we have created about 25 plus centers where one can train from fundamental, being a technician, and use every one of the facility to do manufacturing or design development. And therefore and we have interlinked all of this into our education to see how do we link knowledge and skill together to deliver experiential learning. And so experiential learning should therefore, with all the working in hands-on, lead to questions, I mean inquiry, and that inquiry should lead to more question and understanding and experiential learning, which finally leads to inspiration, ideation, innovation, research, I mean entrepreneurship. and all of them, of course, with greater competence in whatever we do, both theory and practice. So to do that, we have a new framework which is in line with the education policy, and to train for us to go towards this education policy is where the new education policy mandates that we have faculty development programs, and this faculty development program has to address these issues of how do we bring multiple departments together, teach them partly as theory, partly as practice, and link them together with project-based activity to develop competence to design, develop, and manufacture products, or design, develop, and enable services, or design, develop, and enable policy activities. So this is what our education expects us to do. And for that, we have created, a provision of multiple, I would say, silos or buckets. And so we have a combination of all of this to deliver choice-based credit, experiential learning, and outcome-based education. For the sheer lack of time, I will not go into it. But the key, as I said, is that the new education policy wants us to work from fundamentals and move towards an education which will enable us to truly find solutions for the greater good, problems of the future. And just to tell you why education is important, so far Indian government did not bother about education. They thought education ये तो चलता है, मतलब वो वैसे ही लोग बाग और कुछ काम नहीं तो पढ़ना चाहिए ताकि हमें मतलब झंझट ना करे. But now in the middle of the knowledge economy, education is going to be a 10 trillion economy globally, from school to college to skilling to all sorts of lifelong learning. And for this lifelong learning, or about say higher education alone is going to be, depending on whose prediction you go, anything from 300 to 400 billion dollars. Over say 3 trillion. So it's a huge amount of education, and Indian education alone is going to be about 400 billion in the next 10 years, when globally it is going to be 10 trillion. So you just imagine the amount of expectation out of education. For this expectation to happen, we cannot be business as usual, simply teaching them to do some design development and passing exam. We need to make sure that they are future scientists, future engineers, future bankers, future managers, future say social scientists who can go and deal with complex multidisciplinary projects and work on projects which are of greater public good or societal engagement, even as they develop link digital and personal requirements and create product process systems. So it's an entirely different requirement of our education system. And I'll not go into all of this for the sheer lack of time, but we cannot deliver education as business as usual. Everyday class, as much as it delivers knowledge and information and experiential learning, should excite the student and the teacher to take up activities which could be innovative, which could lead to research, product, process development. I'll not go into all these numbers, but so it is a new path. And this has to happen in such a way that we have to be innovative problem solvers. And to solve that problem, we need to first think critically, communicate with each other critically, read exhaustively, and also be very resourceful. And therefore, and also be able to adapt to dynamic changes. We should be able to work across borders and leverage digital capability. So all this is a requirement. And therefore, and this reading and learning, as we said, whether it's a student, institute, government, all of them have to move to a new paradigm, and it cannot be, as I said, business as usual for that. And therefore, our education in the first instance should enable people to know about ways of working, to know about the tools for working, to know about or learn and practice about ways of thinking, and then ways of living in the world by working as an engineer, scientist, social scientist, politician, entrepreneur, whatever. So these are the 4 W's that our education should communicate. And if it has communicated or enabled this efficiently to the student, and for that I have as a faculty developed competence, then I should be able to, as a student or as a teacher, be able to first of all communicate very well, be able to think critically, I mean, using various knowledge, faculty, be able to collaborate with people across board, and above all, be creative, linking this multidisciplinary knowledge. So every domain, it would include many things. I mean, it could, so for example, even if you're working with, say, a bulb or an LED, you have to work anything from electrical energy to biology to material science, physics, computer science, mechanical engineering, chemistry, nanotechnology, and all of that. And therefore, it means, again, working application, software, algorithms, architecture, material processing, structure, device, circuits. So everything is multidisciplinary. And our education effectively, therefore, should first of all enable the foundation literacy in terms of subject capability and all that. Then competences, 21st century competences in the critical thinking, creative thinking, communication, collaboration. And above all, the education should nurture the ability of curiosity, initiative, persistence, adaptability, leadership, social engagement, or thinking about society, sustainable development. And therefore, we are looking at science and inquiry and experiential learning. And therefore, the focus of, therefore, the FDP is to see that how do we now bring in this focus of why are we talking about clean energy? Why are we talking about waste management? And how clean energy and waste management is not just about municipal solid waste, or it is not just about solar energy, but it is about every product, process, system, service that we deliver. We will have to enable it for us to move towards sustainable development or move towards circular economy, even as we move in the age of automation. Anything and everything, whether it is an office, whether it is an industry, whether it is a government process, everything is being automated. So how do we move? Therefore, all these four, just like we are telling about our education, all these four have to now come together critically. And that is the challenge. That's why we are holding an FDP and talking about all of this four. Sometimes it may look, where is the correlation? So it is very difficult just in a few minutes to convey this correlation. But in the next 15-20 minutes, don't worry about the slides you see or slides you don't see. But I just want to say, what is the level of market opportunity? Why we should be talking about, as I already mentioned, circular economy, automation, green technology, and waste management, and the areas where it is being applied. And more importantly, most advanced technology with a bit of creative thinking, multidisciplinary approach and collaboration, we can do it in our own institution. So that is the key point. So if you do not listen or see to any of the PPT in the remaining, say, 15-20 minutes of our discussion, it doesn't matter. All I want you is just to, be sure that, you have got this point, that for all our future development, where everything is enabled by automation, IoT, and Industry 4.0, we need to leverage circular economy, and everything that we do use the principles of reduce, reuse, refuse, recycle, refurbish, all of those parameters. And to do all of them, everywhere we are going to move more towards clean energy. Everywhere we are going to look at waste management or waste optimization in multiple ways. And you have already looked at wide range of waste management so far. You have looked at some amount of material extraction process, some aspect of manufacturing. So now in this next 15-20 minutes, as I said, we simply would see a more diverse set of new emerging manufacturing, which is looking at using lesser energy, which is looking at using new materials, which is looking at abundant materials that use less energy, materials that are less can be easily recyclable. And what are the processes that we could do to do some of them compared to our conventional process? These are something we will, as I said, like passing through a train fast, go through a huge set of points. And as all this is already going to be available on the web, you can go through the video if you're interested in something. If not, just remember that green energy, waste management, automation, advanced manufacturing, and circular economy process and principles have to go together as a system and design thinking overview in anything and everything that we do in the future. So that's all. And that we can do most of this things within our campus. And as I said, therefore, the education, the key, for example, what we deliver in our education has been changing from complex problems, critical thinking, creative thinking, people management, coordination, service orientation, negotiation. Parameters have been changing dynamically, and for sheer lack of time, we will not go into it. But as I said, even the whole education process is about action, reflection, anticipation, and adaptation. The same thing goes into circular economy and automation or control, adaptive control. So therefore, in a way, we are looking at something similar, but for the sheer lack of time, we'll not go and define it anymore. And therefore, in this age of automation, anything and everything is connected. Wired and wireless are all connected together. Everything is enabled by intellectual property. Unfortunately, for India, see, we generate the least amount of intellectual property in this country, whereas the same Indians, when they go anywhere else in the world, they generate intellectual property. And for lack of time, we'll not go into more, but except to say that, see, in 2019, 2018, at the end of 2019, America generated about 21,500 crores of money through royalties and technology licensing, American universities. Whole of India in 2020-21 budget, higher education was roughly the same, 22,000 crores. They only generated from royalties and technology so much opportunity. And we just about invested that money just for our working. And all of our Indian companies, and Indian IIT, CSIR, DRDO, NITs, universities put together, roughly filed the same number of patents as Qualcomm. So it means we need to seriously relook at our education, and that education relook, as I said, has to be multidisciplinary, working across board, looking at critical thinking, creative thinking, and bringing in experiential learning along with teaching. And it is no more teaching to know, giving some information and passing exam, but to know, to learn, to implement, and to do. And from that to do, ask questions and develop innovation. So for the lack of time, we will not go into all of how our Indian education scenario is changing. But it is suffice to say that in the last 1,000 years or 2,000 years, if you look at, India was predominantly a major economy, anywhere from 20 to 25% for most part of the world, to suddenly, just if you're looking at the logarithmic scale, in the last 200 years, we sort of became a smaller part of the global economy. But once again, by 2035 or 2040, depending on how fast we grow in purchasing power parity, we would be the world's largest economy. And we were for more than, as I said, 1,700 years, we were more than 25% of the global economy. Even today, China is 16% of world economy in purchasing power property. They have not even come to the level we were earlier. But we need to go to that level if we have to be the largest populated country, sustain our people, give them jobs. And that job and opportunity is coming through circular economy opportunities and automation or advanced manufacturing. And to do that, again, I want to emphasize using clean energy, grid connected and off-grid connected, managing waste at every process, whether it's a milligram, microgram, or 100 ton or 500 ton, is the key for us as to how do we now manage waste in all its form, whether it is energy, whether it is material, whether it is a sludge, how do we manage them, reuse them efficiently, or minimize waste, are all the key for us to become the world's topmost economy, and without being subjected to some of our islands being submerged due to climate change. And therefore, this topic of today's or this last week's workshop is very, very, very critical. I'm not sure if I'm able to convey the magnitude of importance of why we should do clean energy and waste management in all its facets. It is not just about municipal solid waste or toilet waste or some material waste, but in its complete connotation of every process and system, we need to work on it. And therefore, it's a multidisciplinary opportunity. And for that circular economy to happen, you don't have to invent new things. What we are doing, we will have to improve, subtly change, subtly adopt. And you see, most of the new value creation in every industry, if you see in this, it says there's so many industries, and what is the enabling? Everything is supposed to be knowledge enabled in the future. So knowledge enabled means that we have an opportunity to do something, because it doesn't exist clearly today. Similarly, everybody who was assessed, whether we are working, whether you are a student, whether you are an industry, 90% of the people are saying they are going to get into some form of education. And this education is going to enable huge number of new jobs, which are automation and knowledge enabled, and looking at maybe issues of circular economy and things like that, with new materials, new process, clean energy. And therefore, it is an opportunity for us to truly make use of this opportunity. For example, if you think, it's in data from US, but between 1993 to 2007, about say 17% job was lost due to some form of automation, robotics, adaptive controls. But at the same time, 19% new alternate jobs were created. Whereas in the current automation, nobody is clear what the future will be, what the skills will be needed. So it is but the innovation is an enabler, and therefore circular economy is a key enabler for this innovation, and we need to start thinking about it. And as I said, it need not be huge. You can start small and it then slowly move up. See how we are moving. You need to collaborate. We need to work in teams. We need to work with multidisciplinary approach, but with a strategy and a vision. Only then it will happen. It cannot be in bits and pieces. And that is why also this FDP is very critical. As I said, I'm not sure how much people have understood the benefits, but it's a huge opportunity. And all of this, again, we need to be talking about automation, because on one side, advanced manufacturing and automation is leading to loss of jobs. Okay, in India alone, by 2030, 120 million jobs will be lost by 2030. If so many jobs are lost, how do we create? New job creation can only happen when academia works with local small and medium industry, or by itself develops startups. And these startups scale up to develop opportunities of mass production. And it will never happen if technology is imported. And that is also why we need to be seriously making use of the opportunities. As I said, for sheer lack of time, I will not go into more detail about the various ways of doing automation, various sectors that are giving opportunities. But it is just suffice to say that, see, for any country to grow, R&D is the key. Whenever R&D grows, total R&D, only then a country truly grows. And so far, just by selling, we have been growing. Only by manufacturing from imported technology, that will not happen anymore. And then, therefore, also it is very critical that, of course, India is improving in its global innovation ranking. And also for all of this change, we should be talking about materials, because old materials no more hold good. They have caused all the pollution. So whether it's for energy, whether it's for manufacturing, whether it is for materials, whether it's lightweighting, everywhere we are looking at new materials, new composites, new functional materials, surface coatings, nanomaterial. And therefore, again, when we work with material, how do we work with lowest energy? How do we minimize waste? How do we optimize the process? How do we even truly transform are critical. And that is where also circular economy and sustainability. For example, if you are simply going to use the way, say we are using, say, cobalt or indium at the current moment, in another 15, 20 years, if we don't recycle, reprocess, we will never have any of this material. 30 materials in our Clark's table or our materials chart will be disappearing. But at the same time, we have capability to today design and make materials. So this just tells you how materials, many of these raw materials are going to maybe disappear if we do not optimize and use them, or if we do not find better use. And as we said, therefore, we seriously need to relook at refuse, reduce, reuse, repair, refurbish, remanufacture, repurpose, recycle, recover. So, let us start with all, and the easiest thing to do is to refuse to waste material, refuse to, waste anything, reduce the usage as much as possible, reuse it, repair it, refurbish it. Maybe this repair, refurbish were all part of Indian tradition, but in the developed world, they had so much of money and nothing to care, and they wanted to make mere material that they used to simply throw away. Now, all of them they are re-looking at all of this. So when you talk of circular economy, you are talking of refuse, reduce, reuse, repair, refurbish, remanufacture, repurpose. So it is sort of like the Navagrahas. These are the new nine R's, Navarasas, as we have in our literature. The new Nava R's or the nine Rasas R's are the key for us to move towards sustainable circular economy. And therefore, whether we are working with renewable metallurgy, whether we are working with waste management, we have to look at some of these processes. And that is why in this topic, we have clearly said, it is very critical that again, you see, if you look at the various types of new materials which are being traded across the world, India hardly exports a few things. Most of it is being imported. Even therefore, it is very critical that we work towards circular economy, better energy management, using clean energy, using waste management processes. And so, as I said, for the lack of time, I will not go into all of the detail, but it is suffice to say that please, can you see, when we talk of circular economy, it is in every step, right from, materials, parts, manufacturing, product manufacturing, retail services, from mining. Everywhere you can relook at, retail services, consumer, user, collection, in every process, extraction, waste, we can look at bringing in, steps of waste management, bringing in process of using clean energy. So it's a, huge opportunity. Sorry. So if we work as business as usual, we will be in a very, very dire state. Yeah. And therefore, we need to seriously look at these aspects of circular economy. And the models, as I said, are circular supplies, resource, product life extensions, share platforms. So you need to, product as a service, so that hereafter, soon maybe we will come to a time when nobody will buy a car. Everybody will only rent a car. Nobody will buy a house. Everybody will only rent a house because they find no point in buying it. It is very expensive to build or very expensive to maintain, so they pay rent. So these are the type of changes that are going to expect. And more importantly, as we said, digital technology is coming everywhere. So we may not travel. We will use IoT. We will use RFID. So many, many changes in biological and physical technologies are happening. So all this, I think, gives us an exciting opportunity. Sorry. Maybe, the network is slow. Am I audible? Hello?
Yes, sir.
Yes, sir. Yeah.
Yes, sir. Yes, sir. You are audible,
Okay.
sir.
All right. Again, as we said, a lot of things are changing, and for the lack of time, we'll not go into it. But therefore, if we don't address sustainability and circular economy issues and associated clean energy and waste management issues, see, there will be loss of supplies, loss of water supply, loss in sanitation, breakdown in transport and communication. So many issues, loss of livelihood, extreme weather-induced illness, vulnerable communities. So, the list is, very huge. And therefore, I hope you just understand the magnitude of why we were discussing this, and that it is not restricted to just some waste management or some material extraction, but it has a huge context and across the board. And for, as I said, lack of time, I will not list out or read every one of this. But the key is, for these things to change, We have to change right from our market, supply chains, operations in every process. And the first enabling has to be clean energy. And clean energy, and again, things like renewable energy is a huge opportunity. I'm sure you all read about the COP 26, how India has committed a huge amount of commitment to carbon dioxide reduction, commitment to using of clean energy, and clean energy in all its facets. And more importantly, we all need to remember that clean energy usage, not just from the power source or plugged in, but off grid alone is a $500 billion opportunity. Whether I'm using my mobile phone, touch screen, IoT based controlling of my house door or computer, TV or cooker, or whether I'm doing my body wearable electronics for drug delivery, all of this can also be controlled. So, and the off-grid power, I mean, when I'm driving itself, I charge my car or a two-wheeler through solar to regenerative braking to, wind energy. So all sorts of, off-grid power utilization from microwatt to megawatt opportunities also exist. So we need to look at how do we now think and create these opportunities in anything and everything that we do in terms, as I said, or even for batteries, recycling and sustainability of battery. So this is just to say that when we are talking of green tech, it is energy in all its, from biomass to green, wind to thermo EMF, because energy harvesting and scavenging, photovoltaic, to even say things like wave energy, and also storage reusing. So it's a huge, and it involves everything from materials, processes, systems, software. For the, as I said, sheer lack of time, we will not go into all of this, but I hope you understand that what is the magnitude. The only point I wanted to convey from the beginning till the end is the magnitude of opportunity is huge. And so, and again, for each opportunity, there is if I just say off-grid power without connection, so it from enabling technologies, utility behind the meter, batteries, electrical vehicles, smart charging, power to heat, power, renewable power to hydrogen, Internet of Things, artificial, big data analytics, mini grids, super grids, flexible power stations, and business model of aggregator, peer-to-peer support, energy as a service, community ownership, market design, and even enabling system operators. Here also, everything you will see that these are all multidisciplinary opportunities which we could do in our academic system. And similarly, if you're looking at advanced manufacturing and automation, it looks at, say, growing manufacturing productivity and also potential change in ways of employing. If you look at the two chart, you will see that India is placed somewhere here in the sweet spot of both delivering quality manufacturability and also getting jobs, whereas the developed countries are in this bottom cycle where they cannot grow jobs, they might not be even in a position to grow, and therefore they will have to buy from us. So that's why in the global value chain, India is very well placed. But then it is up to us to leverage all this opportunity using cutting-edge state of technology, great energy efficient, clean energy technologies, minimizing waste so that our environment doesn't get spoiled, whether it is agriculture, whether it is a manufactured product. So, and this, I think I'll not go into all of this, just to say that if you're looking at IoT, there are so many, computer-based technologies, storage-based technologies, operation, software, hardware, so many things go into it. And in every one of them, there is possibility for energy efficiency, there is possibility for waste management. Similarly, if you look at, the network and the connectivity opportunities and what all can you do, again, there are huge. So please don't think it is just material processing, but every device, every process, every system. You just look at, the amount of electronic devices which would be off-grid, IoT enabling, or health delivering, or environment monitoring, or industry process optimization. You will see that there is a huge set of things happening, and all of them, as I said, are connected. And we need to therefore think of circular economy, and that circular economy cannot be only optimization, it has to be a transformation. Only then we can survive. Same there, similarly with respect to, automation. In the age of knowledge economy, the automation also has to be, optimization has to work with sustainability, and with the changes have to be fast, and it needs to be again globally linked. And All this can be conveyed in our education. Everything has this, just to say the type of materials, electronics, mechanical, computer science, everybody can be linked in this. And so as we said, we have over 30 labs to deliver some of this knowledge, and it links every industry. And therefore, because automation is expected to, say, increase labor productivity, reduce labor cost, mitigate efforts of labor shortage, remove clerical, manual and clerical jobs, and therefore even error and increased efficiency. So all these are benefits of automation. These are examples of so many things that automation can do. For lack of time, as I said, I will not go into all of this, but to say that it is, and in every one of them there is energy issues, there is every one of them waste issues, there is every one of them material issues. So can we look at all of them with a system and design thinking overview in an integrated way? That is what we want to convey. And so therefore we need to look at the bigger picture, multidisciplinary total overview, and also look at new material, new devices, newer system. That is where as an academic we can publish, but the assignments have to be day-to-day problems where students do hands-on. And therefore we can also link to industry and deliver product, process and solution. And all the funding, you see, just engineering has the lowest funding in research, 24%. But computer science, biology, social sciences, simulation, environment, they all have funding which is huge. And therefore, we need to understand that we need to work in a multidisciplinary way when you're looking at environmental, social science, biological issues, even for manufacturing. Therefore, also clean energy and waste management are very important areas, but not looked at as just some small municipal solid waste or some metal extraction, but holistically as a mind-blowing opportunity. And it has to happen through R&D. R&D is the only way, and that R&D has to come from us, from academics. And also, as I say, it links every possible technology. And this is just to say automation will be enabled by IoT, and that IoT again, man, material, environment, systems, production, all sorts of things are linked. This is just to say that, again, newer material, newer process, 3D printing, screen printing are all coming into existence. And so we are coming away from just, on one side we say electronic chips, other side is potato, but then today even from potatoes we can draw out cellulose and do electronics by printing of ink on paper and plastic. So that is the type of thing, and in every one of them we need to look at energy efficiency and energy management. This is just to say, just packaging alone will tell you the shelf life, it will tell you what is the quality of the material, what is the state of the material, what are the, if I open it, what could be the VOC coming out, and all this would be electronics done on paper, plastic, ceramic, or a bottle of medicine. So, and this is supposed to be, again, say, billions of dollars of market opportunity. So therefore, as I said, I just want you to open up your mind to look at opportunities of waste management, material management, clean energy, all the electronics and the energy generation which can be used and throw or on my body or in the environment could be coming from large area, flexible, printable electronics. So that is a 500 billion opportunity. And these electronics can be on glass, paper, plastic, ceramic. And this is just to show how electronic circuits and all are being on plastic circuits, and drug delivery systems are being made, printed drug needles, patch, I put it on my hand and it will deliver whatever micrometer along with electronic control. If I need to be delivered 10 microliters, it will deliver 10 microliter of my diabetic insulin or whatever medicine. This is just saying example of our pressure sensors working, and wearable electronics, or wearable for environment monitoring or even production and process optimization could be linked to it, so that errors could be minimum. As I said, for lack of time, I'm not going into detail, but just showing you some images. And so how on a single sheet of plastic you could have energy generation, energy storage, driving electronics, sensors, control electronics, all of them. And the application could be autonomous car, agriculture, parking, manufacturing, mobility, waste management, remote health, smart building, smart city, heating, energy, animal tracking, apparel, aircraft control, pollution control. So these, therefore, and just an car alone has to be monitored prognostically right from its petrol or electrical battery to its transmission and power management to safety, security. So therefore, the connotation for energy generation and waste management, as I said, is huge. Just this is the canvas, and all types of devices and sensors are coming up. And when I say wearable and stretchable electronics, it could be on people, it could be on animals, it can be on buildings, it can be on cars. And all this will go into through and will be made through MSMEs. India will soon have 100 million or 10 crore MSMEs, and that MSMEs have to be enabled by education from institution. That is where our opportunity comes in as we build smart cities, smart energy, or even construction materials are becoming smarter and we leverage big data. So, I mean, we can work on all of this with multiple of these steps. For the lack of time, I am not going into detail, but these are the steps we need to look at. How do we link all of this and work for our growth? But as I said, but the growth has to be transformational. It cannot be optimization and micromanagement, but it has to be truly evolving transformational growth. Only then we can be successful. And the transformation calls for innovation, and the ability, the thing that enables us, I want to call it as a device which enables this innovation. I'll just finish in under 5 minutes, sorry. And this part of our conclusion of the, I'm also highlighting why all of this, to also say that why we were doing this workshop and why it is critical. We need to have these points which may or may not have been discussed in the previous 14-15 session. So the innovation has to be enabled through a device. The device, I call it as desirability, effective feasibility, viability, inclusivity, and sustainability. Whatever we do, product, process, service, can you look at this DEVIS? If these 5 can come in, then the innovation will be successful. Scientists and engineers have to work towards and jointly enable this innovation. And it's up to us to make it happen one bit at a time. It need not be massive. Well, don't think of it as a big activity, but modularize it or break it down to small things and see how you can manage. As just now in one of our previous research committee, we are talking, it is like saying the largest of the longest walk or longest climbing of a mountain starts with a single step, or any, I mean, say activity starts with one step at a time. Even if I have to eat everything, I need to take one gulp at a time. So we have an opportunity to link and do things. And this is just to say that how from electric car to agricultural vehicle, race car to robots, wearable, all things were made from first year assignment projects with small amount of materials and waste material and first year labs to components for automobile industry. Here we have given a collage of information of what was made. And I'm just showing that how, say, future electrical mobility will need so many things. So can we now as a team work together, because everything is going to be electrical. So can we work as a team to enable this electrical, cars? So again, this would need lot of material, lot of activity. I mean, and every one of them needs from battery to energy to composite materials to drive electronics. I mean, so many, I mean, software, tires, everywhere you will see that lot of multidisciplinary activity is there. So and these material devices can be hereafter made roll to roll on even at nano dimension. These are new technologies that are coming up. And this is just to say that from solar car to satellite, drones to aerospace material, I mean, race cars to hybrid vehicle were made by students and at a very suboptimal cost by doing design and then going to industry and getting from them supplies or measurement instrument or subcomponent. So for example, all this activity, if we done on our own cost, if it had to cost 10 crore, maybe in my previous institution where I headed, maybe we spent annually 20-25 lakhs. But all of this is also divided into assignment and project cost in the labs. And from there, it was integrated into a product. So just to say that, and some of this activity led to my students setting up a battery company, lithium-ion battery management. So this company is now up and running. In 2 years, these students in their first 4-year engineering learned enough things that they have set up a complete factory to reprocess waste from lithium battery, from the race car that they made and the problems that they faced with the lithium battery. And also they developed a technology to do second use battery from old battery, which is half the cost but can deliver the same capability. So this is again to say that, see, a solar cell on glass was made in an Indian lab with equipments developed by ourselves. And these technologies for nano pattern, we can use something called nano imprint lithography, where you can create 10 and 100 and 200 nanometer pattern without mask over meters together. You can develop new materials for antenna, all sorts of processing equipment from polymers to 3D printing, combining metals and ceramics, combining ceramics and plastics. We have developed indigenous process equipments which are used to make products for aerospace, for ISRO, for defense. So this is just showing equipments that, again, using simple off-the-shelf component, whole of, I mean, say, hand weaving industry, cottage industry is automated so that they can deliver 10 to 15 designs every day rather than setting up one design and working for a month and changing design, or using even waste material to, I mean, say, finding small equipment to find out how do you feed the silkworm to get, I mean, better, I mean, silkworm yield by just finding a temperature and humidity of the environment. So we developed a handheld device, and this led to now generation of higher quality silk. So this is just to say that so many opportunities, process equipments. For example, combining metals and ceramics, we developed magnets of very high capability. And normally the process needed, say, about 2000 degree, then we created a vacuum based induction heating and compression capability, so we could make pellet and then compress them and then make new materials, or extrude them to make wires or tubes. So this is just to say that all sorts of capability can happen, and these were all made in few lakhs of rupees, working with local companies. This is for extrusion of polymers. I mean, whether you want to do solution for painting, we can combining nanomaterials and polymers and glass fibers, or whether you want to make rods out of it, you could look at working with some of these equipments all made here locally. And this is just to, and as I said, therefore materials are the key. So we can forget about just how, not forget, we need to, on one side, how do we optimize extraction, whether it is silicon, whether it is iron, whether it is aluminum, and the other side, look at how do we create these materials with new processes like thin film, so that you can grow them over large areas, and where you earlier used, say, 1 millimeter, you might literally use 100 nanometer. I mean, order of 10 to the power 3 lesser to create material from cathodic arc, ion plating. I'm just giving names. So for example, this cathodic arc, earlier, whatever materials are grown at 1200 degree, today you can grow over meters together in room temperature and give the same property of the 1000 degree. And earlier, if you were doing 10 or 50 micron, now you only need to do 100 nanometer material, and faster and lower energy. So when you say energy efficiency, when you say waste management, it can also be in processes like this. Or so the same material can, instead of using 1000 degree metal oxide, now can directly be used for coating in VLSI design as a low-K dielectric. And it can be used for making sensors, and electronics, plastics, circuits can be now made over meters together when you use process like screen printing, inkjet printing, plasma processes. And that is what is used to make our LCD display to PDP, where, I mean, the devices are 110 inches. Or they can be done roll to roll. And these are examples of, as I showed earlier, so India's first satellite, India's first solar car, which ran a 3000 kilometer rally in Australia, the first car, the second, this is the first car, yellow, blue is the second car. And first year assignments, battery and solar based cycle power to agricultural machine, complete indigenous facility to manufacture these devices and systems over large areas, made in India. And this lab, whatever was 1,500 crore in IISc, was created for literally 80% capability at 20 crores. So, and each small equipment, 2 lakh, 5 lakh, 7 lakh built, and then all this technology, again, indigenous process-based factories have been generated when the partners whom we worked can create such roll-to-roll processes for large area fabrication. So, and we can make nanomaterials, atomic smooth films, fibers, all at near room temperature, what was earlier done in 2000 degree, or create nano pattern. So this is just to say how we can do so many things, or as we said, even complete water management, waste management, to tree adding, and along with, say, surface coated added windows for optimizing. So whole of the campus could become sustainable. And because it became sustainable, you will see that, I mean, migratory birds started coming into the campus. This is just showing how water management, waste management, even the air conditioning used less water and more of air, and optimized processing, so that water usage is less, more air is used, and more optimized cooling. So solar panels, even our own campus here has close to 260 degree solar panel. From this, we can even study and optimize the use of solar panel for elsewhere. And every process, drilling, milling, cutting, was used to study process optimization, optimization of energy, optimization in coolant usage, optimization in material usage, optimization in tool usage with appropriate parameters, so that energy efficiency could come in, material usage could be reduced. reliable products could be made for even MSMEs. So these are such example, and nano patterns generated, or using some of this process today from our lab technology. A factory has come up in Delhi, which is now making diamonds produced in the lab. Earlier, you used to only expect these diamonds to come from under the ground. But today, these technologies have gone up to make indigenous, say 1.5, 0.92 and 0.5 carat diamonds made out of indigenous process. So the key point, as I said, was to convey that many things can be done in the lab, and you could even use process like pulse laser ablation, screen printing, inkjet printing. All this can be used to produce materials which could be amorphous, nanocrystalline, nanocluster, microcrystalline, polycrystalline, crystalline, and use them, as I said, to make, compared to the conventional process like casting, forging, forming, rolling, extrusion, all of this with low energy, larger area capability. For example, this is a lighting system which we can literally do in a bulb factory, and we have done with a material grown at room temperature. This is, and using even lesser energy than LED. So this is just to say, so many process equipments, processes, measurement equipments, and some of that led to over hundreds of millions of dollar benefit for over 300 companies where student did projects with the company. And there's some of the companies where this happened include some of these names here. And there's once again equipment material. This is just, as I said, or even agricultural waste reused for cardboard to ply to building materials. So, and all sorts of feasibility. So can we open up our eyes and start working? Say waste gas to cooking, water treatment in the campus, all refurbished and hardly done with 30, 40 lakhs. A 50-acre campus was refurbished after 50 years to become fully sustainable, zero water discharge camp, or waste to gasification for cooking. And even coal waste with chemical processes converted into clean fuel and fertilizer. Biomass-based power generation, all sorts of agricultural waste were combined to make pellets of appropriate calorific values, biomass-based biofuel generation and their testing, or food waste and agricultural waste and milk and converted into useful, long shelf life, agricultural, nutritious meal. So that's the key point, as I said, was it's up to us now to look at how do we look at waste management? How do we look at energy management? So we could do wonders. So this is again, including robots, solar thermal receiving tubes, and I have shown. So I just close here. I think I've taken a bit longer than expected, but the key point in the valedictory also we want to convey is that, see, we have heard so many people showing exotic facility and showing they can work. But I say that with simple processes within our academic process, we can work. And here again is a list of processes we are trying to build into our academic process in the university to see that how do we ensure we bring knowledge and skill together, first to understand the subject, then to develop competence to design and development product and systems. And whenever we work as a multidisciplinary team, industry research shows that any homogeneous team initially may look to be faster in the initial stages, but as it gets into actual process, product development, normalizing and performance development, a multidisciplinary team always delivers more. And that is what we as universities have an opportunity which the industries do not have, and also industry don't have the time to do the transition. And most of the changes need not be new invention. In the age of circular economy, it is, as I said, all the 9 Nava R's that we discussed in the beginning of circular economy, and also using of clean energy in all its facets and formats, or energy harvesting and scavenging. So that is why this topic was given, though we are sorry we couldn't truly discuss all the application and feasibility under the green energy and energy harvesting, scavenging, nor under waste management. But I hope I have given you some example of the diversity of opportunity, and also simplicity, that without reinventing, I could still do so much more. And if we do that, I think we will be truly getting into an age where we work with industry and we can deliver unlimited. If anything can limit us, it's only our imagination. Otherwise, it's truly unlimited opportunities. And I want to call this as the 5 Indriyas, or the Nava Kavacha Cs. So in our education, can we just look at anything and everything that we do at information inquiry, innovation, implementation, and impact? How does it enable this? And to measure it, can we look at, has it led to curiosity? Has it led to critical thinking? Has it led to communication, collaboration? This is where our assessment, continuous formative assessment, should enable these. And if it can do, wonders can happen. We are already working with so many companies and trying to make some of this happen as a new university. So the modes of engagement, whether it is with all of you or with the local industry in your own, it could be, as I said, offering joint courses, credit exchange, joint research, student skilling certification we can offer from some of our facility, jointly help in setting up labs, PhD, faculty exchange, student project, faculty training. So many things can be done. I mean, for us to see how do we leverage this FDP beyond this FDP. And so once again, I finish with saying that this FDP was focused at, and the topics were so chosen that can we tell our colleagues that we don't have to go outside. If we can start working together within our own departments, our neighboring departments in our university or our college, we have a huge opportunity of delivering many opportunities in clean energy, energy harvesting, and energy scavenging, in waste management and optimization, and also developing transformative disruptive technologies. Because circular economy is not asking me to completely change everything. It is saying in every one of my existing process, what all the transformation can I bring in so that I reduce my energy usage, I refuse, reuse, all the 9 R's. So I hope we have given a flavor, and also as a part of the valedictory wanted to give an overview of what is the opportunity, and also showcase that all this can be done, because as you have seen, from aerospace to automobile, energy to food technology, advanced manufacturing to defense, we have showcased so many technologies made in small academic institutions. They are not IITs and IIScs or NITs, but then these are all new institution or old institution being refurbished. And the same faculty who for 30 years couldn't do anything, in next 3 years could create wonders just with a change of mind and working together. So this is what we wanted to confirm or convey. Thank you once again for your patience listening, and sorry for the multiple disruption during the presentation initially. And hopefully we have conveyed the essence of what we wanted to do in this. And so if we have understood that, I think that itself is good enough for us to get starting to collaborate with each other. Thank you very much.
Yeah, thank you, sir. Thank you for your insightful talk, sir. Thank you again, sir. So next, move on. So I request participant, please express your views on this FDP. Participant, please, anyone.
Good evening, all.
Yeah, good evening.
Good evening, please.
Bubbly Varsha.
Yeah, Bubbly, please go ahead.
Yeah, sir, I am really feeling delighted to be part of this faculty development program and got great experience. The sessions are with different topics and techniques, and lot of opportunities are there. The topics are very informative and valuable. I am really pleased to be the part of this. Thank you, sir. Thank you, ma'am.
Yeah, thank you, Bubbly. Thank you for your means. Yeah.
Yes, ma'am.
So, yeah, thank you, Bubbly.
Thank you, sir.
So, anybody, participant?
Good evening, sir.
Good evening, madam.
Sir, I'm Dr. Shubha from Don Bosco Institute of Technology, Bangalore. Sir,
Yes,
all
madam.
the sessions were informative and it was well organized, sir. Thank you very much. Thank you.
Thank you, madam. Thank you. Any other participant, please express your views.
Good afternoon, sir. Myself, Rupambika Manti.
Yeah, madam. Carry on.
I am working in LN Intake Services. It is a startup company here in Bhubaneswar. The workshop taught us very practically of implementing critical things. It's very helpful. The level of expertise and knowledge of of the all presentators are excellent. I got great educational experience. It is outstanding and mind opener. Thank you, sir.
Okay, thank you, thank you. Any other participant, please? Okay, so now I request our HOD Madam, Professor Ranjita Mohanty, please address the closing ceremony to the gatherings.
Good evening to all the dignitaries present over here and Vice Chancellor Sir of CGU, the Professor Dr. V. Satyanarayan Sir, and other participants, delegates present over here, my colleagues and my staffs. So now it is a coming to an end session. So we have already gone through 5 days of FDP program and 14 sections already over. In the 14 sections, we have gone through different types of lectures and different from the different resource persons. So as I am very much thankful to AICT, so who have given the opportunity to conduct this program, and their financial support help us to conduct this program. So thank you AICT. And I have also thanks to my organization who is giving an opportunity to organize this session very smoothly and conducting this program smoothly so that it will coming to an end and completed successfully. So in this program, this is the program, the green technology and waste management, the era of advanced manufacturing and circular economy. As our Vice Chancellor sir already has given a focus on this program, who will be who will also focus on our organization, how it will be working on this green technology. Our campus is getting some award for green campus also. So, on behalf of my organization, Sibiraman Global University, I am thankful to our Vice Chancellor sir and President sir, my Vice President sir. So, who have given us some opportunities and support so that we will conduct this program very successfully. I have also not the last, but what will happen when we are coming to any session or any program, the supporters are many. So the supporters are my colleagues, my staff members, electricians, then computer session, and other staff members and technical staffs of our organization. So I am very thankful to all of them, and the participants who are the members of this program. They are the most important persons who will take part in this program, and they're giving their time and patiently listen to all the sessions carefully. And I am very thankful to all the participants for their participation. Uh, they I know they have taken some pain to meeting these sessions because they have their own work and they are all are academicians, I can understand, but thankful to them. And I just want to say another thing that we have already gone through many sessions, and the sessions are covered so many different types of sessions, different areas. So on these different areas, we have covered waste technology. In the waste technology, some of the parts are under mineral processing, material station, and some of the parts from the biofuel and biocarbons, their pollutions, how this crisis will be there and how will coming out from this. So different types of presentations will giving you different types of knowledge gaining. So we have also gained some knowledge from different resource persons. So with this I just conclude this section from my end. So I just request my coordinator and Mr. Rudranarayan Mahapatra, yes, to take the chances, and he will just tell something because he has successfully completed this program, and I am thankful to him very much. Okay, thank you, sir. Thank you all the participants.
Thank you, madam.
Thank you.
Okay, so move on. Now, I request Professor Rudramohan Mohapatra, coordinator of this program, please give the vote of thanks. Please, Rudra sir.
Good evening to one and all. Giving my opportunity to express my gratitude on 5 days of the online faculty development program on green technology and waste management, the era of advanced manufacturing and circular economy. One a great man is not giving thankfulness and not expressing it. It is like a raving of present and not giving it. Today I take the opportunity to all my gratitude into what? First of all, um, on behalf of my organization, I thanks to our president and vice president of university for their support to conduct the program and successfully complete the program. I thank to our chairperson of FDP, Professor Dr. B.S. Satyanarayan, Vice Chancellor, CV Raman Global University, our guest of honor, Dr. Priyadarshi Kanungo, Priyadarshi Kanungo, Dean Engineering, CV Raman Global University, and Dr. S.K. Biswal, Chief Scientist, retired, Head Chemical Engineering, CSIR, IMMT, BBSR. So our chief guest, Dr. Sunil Nanda, Director R&D, Titan Clean Energy Project Corporation, Canada. I also express my gratitude to our advisory committee, our Dr. Ranjita Mahanti, Dr. HOD Chemical Engineering, Dr. Anup Kundu, co-coordinator of FDP, and other staff member. Those can help in this FDP. I, on behalf of management staff and all participants, would like to express my heartily gratitude to all my eminent speaker. First, speaker there, first sparing their precious time. I thankful to Dr. Sunil Nanda sir, Dr. Ritesh Malani sir, Dr. Krishna Prasad sir, Dr. Rusika madam, Dr. Ashok Matani sir, Dr. Ranjita Mohanty madam, Dr. Vinod Kumar Raja sir, Dr. Prashant sir, Dr. Sujit Devnath sir, Dr. Vijay Kumar Bulasara sir, Dr. Vivek Kumar Bansal sir, Dr. Sunita Rautray madam, Mr. Prabhakar Sethi sir, Dr. Surender Lal Pal sir, and Professor B.S. Satyanarayana sir for presenting their innovative work. So last but not the least, I heartily thanks to AICT and their teams, sponsoring teams, team members to support me for conducting the faculty development program. Thank you.
Okay, okay. Thank you, sir. Thank you for your vote of thanks. Now I thank our honorable Vice Chancellor, sir, our HOD madam, our the co-coordinator, and all the participants. So thank you. So I am just closing this session. So means in near future, you again we will do this type of FDP. So again we will mail to you all these participants. Thank you again. So now I'm closing this session. Thank you. Thank you, sir.
Thank you. Thank you. So there is an exam which is started from 5:30. So you can get the Google link. In that Google link, you just fill up it and submit it within the time. Okay. So within 5 minutes, you can get this link. And one more thing I can tell you that you just fill up in AICT, that is the feedback form. If you not fill up the feedback form, you are not getting the certificate. So just go to the feedback form AICT link and just fill up the feedback form.
Okay, so it is almost 7:25. Means okay. So within 2-3 minutes, we will send the test link. So you will get through your email as well as WhatsApp group. So please means answer the question. Okay, and best of luck. Thank you.
Thank you, Anup.
Yeah, thank you.
So we may leave now.
Yeah. So we
Thank
are
you so much,
closing.
sir. Thank you.
Yeah. So we are closing this session. Thank you.